I was going through some of my electronics projects and I realized I hadn't made a video about this one, so here we go. I'm Timber Monson and this is my Arduino CO2 sensor slash VFD display. What it's doing is it's reading the ambient CO2 level in parts per million and displaying it on this old stock vacuum fluorescent display. The reason I made this was I was just doing some internet research and I had stumbled upon some of the importance of indoor ventilation, specifically CO2 levels and how quickly they can climb with just two people in a room, and how quickly they can be biologically significant. Up to around 3,000 parts per million is considered safe, but its effects can be measured as low as 1,000 parts per million, which you're reading now, partially because I'm breathing on it. So how it works is this is the star of the show. It's a dual beam NDIR and CO2 sensor. It uses infrared interferometry to read the gas level, and it has a second infrared light source as a reference, just to keep itself calibrated and in check. You can get this sensor off of Mouser. It's called an SCD-30. I chose the Adafruit version with a backer board because I'm using 5-volt logic levels, and the sensor needs 3.3. The Adafruit version adds a level shifter. And that's being talked to via this Arduino Pro Micro. It's just a really basic knockoff. You can get $5 versions on Amazon. And it's using I2C to talk to the sensor and get these readings. It can also set some calibration procedures if you want. And so to display to the tube, I have to go through a quick rundown of how vacuum fluorescent displays work. In short, the first component is a tiny little filament wire that's running across this. All that does is it takes in 2.2 volts from this buck converter, and it just stays a little warm inside that tube vacuum. Now, when you got a warm wire inside a vacuum, what it does is just boil off electrons, and those can be accelerated in the direction of anything positive. So, to light up a segment, one of these little bits of metal that make up the segments of the digits is charged to 30 volts, and it's coated with phosphorus. So, these boiled off electrons accelerate towards the segment, strike it, and light up that phosphorus. This display is also multiplexed, meaning all of these segments are wired in parallel, and I can only light up one at a time, so I gotta cycle through them very fast. And so to choose which segment lights up, there's an additional component called a gate in front of each of these digits. Now, each metal gate is set to 0 volts for an inactive digit, and that essentially means that the electrons won't want to go towards the gate. Now, for the segment that I want to light up, I'll set the gate to 30 volts, and the electrons will accelerate towards that little mesh gate, but it'll go through it because it's porous, basically. And so if I can light up one digit at a time, I can, for example, set the C, I can light it up real fast, and then move to the next digit and light that one up. And so I'm cycling through this constantly. And thanks to persistence of vision and also the fact that phosphorus kind of has a delay that it stays on after you've struck it with electrons, I get a persistent image. Now, how do I set these segment voltages? They're 30 volts and the Arduino is 5. Well, that's thanks to this other chip. It's basically just a high voltage shift register. It takes 5-volt logic and a 30-volt reference from this boost converter. And by just clocking in data really fast, I can set these segments to whatever I want. Now that I've had that all set up, I can start doing little stretch goals. So for example, this sensor also has ambient temperature readings in Celsius and Fahrenheit, as well as a room humidity setting. Now, I wanted to add as much functionality as I could with this single button in the back. So there is an additional mode where if I plug in the power while holding down the button, it enters a settings menu. And I can quick press to cycle through menus, things like self-calibration, enable, disable, recalibration enabling. I can just do trigger by pressing a long press. So I've managed to get CO2 sensing, humidity sensing, and a little settings menu out of just an Arduino, a single button, and an old stock Soviet-Russian IV-21 vacuum tube. And that was bought off of tubes-store.com. Took a while to ship here, but all in all, this was a really fun project to make. All the soldering was done by hand, and this was pretty rewarding. Oh, and the last thing is this little cover was just something I designed and 3D printed. Just acts as a dust cover while still allowing gas to transfer. So yeah, that's my Arduino-based CO2 sensor. Thanks.